In this project, I'm going to be testing the accuracy of Reimanns sum. Reimanns sum is an approximation underneath a line or a curved line on a graph. So to do this, I went on a road trip that was more than an hour long, and every 5 minutes I recorded the speedometer and the odometer. And I wrote down how many miles I traveled in each 5-minute intervals. And if you notice, from 0 to 5 minutes, I only traveled 1 mile. Now that might be a source of error that I'll talk about later. A lot of people can run that fast. The average is 3.5 miles. So I took my data and I made a graph of the left-bound Reimanns sum. And I took my 0 to 5 intervals as my x and my speed as my y values. So if I blow this graph up so that you can see a little better, and I get rid of that Reimanns sum, and now you can see how I plotted this graph. So at 0, 0, I'd gone nowhere. That's right there. After 5 minutes, I was going 34 miles an hour. After 10 minutes, I was going 52 miles an hour. And so you can see how I plotted this graph. Now the area under the graph is going to represent the miles traveled. So technically, you can count up each little square, and you should get about 36 squares added underneath this graph. But another way you can do it is through the Reimanns sum. Now, since this is left-bound, I'm going to take the left side of this interval from 0 to 5, and it's 0. Now, you may be a little confused, but let me keep going. Maybe you'll catch on. Different color. Now, my next interval is from 5 to 10. So I'm going to take the left side of this interval, and I'm going to trace it all the way up to where it meets the function at 34, go across and down. I'm going to do the same for the from the 10 to 15 minute interval. I'm going to take the left side of the interval at 10, go all the way up until it meets the graph, across and down. And you can see how I've done this for the entire graph. And once you've done it for the entire graph, then you can simply multiply the base times the height to get the area of this block. And so if we calculate the area of this red block, it would be 5 times 34, which equals 170. Now 170 doesn't seem right because our units are a little messed up. From 0 to 5, that's 5 minutes. From 5 to 10, that's 5 minutes. And we're trying to get it in miles per hour. So we're going to divide 5 by 60. And when you divide 5 by 60 and multiply it by 34, you get 2.8 miles. Now, if you remember from the data, we only traveled 1 mile in the first 5 minutes. And using this Reimanns sum, we have traveled 0 miles in the first 5 minutes. And we're going to get into how that works, and we're going to take the right bound, and we're going to take the average of the left and right bound. I'll go through all of it. But if we take the area of the second block, it's going to be 5, remember 5 divided by 60, and times the height. The height's going to be 50 times 52. And when we plug that into our calculator, or we do that in our head, better yet, it's going to equal 4.25 miles. And we traveled 4 miles from the interval 10 to 15. And so that's actually pretty accurate. It's a little off because you can see here everything above the graph is error. And vice versa. Everything that's not accounted for right here is also error. And when we calculate the area of all of these rectangles or blocks, we're going to get a final area of 37.66 miles. And here I've made the right-bound Riemann sum. So I still have my same data coordinates of my x and y, and I plotted the same exact graph, but now I'm going to do the right-bound Riemann sum. So for my interval from 0 to 5, instead of starting at the left side, I'm going to start from the right side. So I'm going to go up and up until I hit the graph at 34, go down, or left, and then down. Same thing for the next interval. From 5 to 10, I'm going to start at 10, go up until I meet the graph at 52, go across, and down. Now again, everything above this line is error, just as everything above this line is also error. But when I average the two Riemann sums, the left bound and the right bound, it will kind of balance that out a little bit and hopefully be pretty accurate. Now I'm also going to do the same thing as I did on the left bound. I'm going to multiply the base times the height. And when I find the area of each block, I'm going to add them up, and that's going to be my total distance traveled. And my total distance traveled when I added all of the areas up was 40.15 miles. Now that's 4 miles more than the 36 miles I actually traveled. And if we remember, if we go back to the first slide, in the first interval from 0 to 5, I only traveled 1 mile. When we average the right-bound Riemann sum and we average the left-bound Riemann sum, we get a total distance traveled of 38.9 miles. And that's a pretty good estimation from using Riemann sum, because my actual distance traveled was 36 miles. And so Riemann sum is a good way to estimate distance traveled when you don't have all the tools you need to accurately calculate your distance traveled. A couple sources of error when I was in the car driving was, first of all, my sister would accelerate and decelerate and accelerate and decelerate, causing a fluctuation in speed, which translates into a difference in distance traveled. And at one point, we were also behind a construction truck for about a mile, and that's one reason why from 0 to 5 we only traveled 1 mile. If we wanted to make the most accurate Riemann sum prediction we'd try and be as consistent as possible. I would drive on the highway on cruise control for 1 hour, and I'd do the same process, but the Riemann sum estimation would be a heck of a lot closer, if not exact, to the actual distance traveled.